Hello, space enthusiasts. Ever pondered the origins of Earth and Mars? The endless cosmos has always been a source of deep fascination and curiosity. Now we find ourselves on the brink of a new understanding. Groundbreaking research has recently shed light on the building blocks of Earth and Mars, unfolding a tale as old as the solar system itself. So brace yourselves, as today we're diving deep into the mysteries of our planetary beginnings. To understand our origins, we first need to explore the theories of planet formation. Picture this: you're in the early solar system, and it's a chaotic scene. Dust and gas swirl around, gradually clumping together over millions of years. This is the classic theory of gradual accumulation, where planets form bit by bit, like a cosmic snowball. On the other hand, we have the migration theory. Here, imagine tiny dust pebbles, each one insignificant on its own, but together, they form a moving, flowing river of dust. This dust river migrates around the solar system, gathering up material as it goes and forming planets along the way. But it's not all as straightforward as it sounds. These theories have evolved over time with new research and discoveries. For instance, the gradual accumulation theory was once thought to be a slow and steady process, but recent findings suggest it might have been more of a rapid, chaotic affair. And then there's the migration theory. It was once believed that dust pebbles migrated smoothly and predictably, but now scientists think these pebbles might have taken a more erratic, unpredictable path. Each theory paints a different picture of how our red worlds, Earth and Mars, might have formed, but a recent discovery has put these theories into question. So let's fasten our cosmic seatbelts and delve deeper into the mysteries of our planetary origins. Prepare for a cosmic revelation that will change your understanding of our solar system. Picture this: the vast expanse of the universe, galaxies forming, stars exploding, and amidst all this cosmic drama, our solar system taking shape. This is where our story begins. A groundbreaking research led by the University of Munster in Germany has made a startling discovery about the building blocks of Earth and Mars. Now imagine a boundary line, a cosmic divide if you will, drawn around the orbit of Jupiter. Everything within this boundary is the inner solar system, and everything beyond is the outer solar system. The popular belief was that the Earth and Mars were formed from a mix of materials from both these regions. But the latest research has turned this belief on its head. The scientists found that a whopping 96% of Earth and Mars building blocks originate from the inner solar system, a region closer to the Sun, and a mere 4% are from beyond Jupiter's orbit. This discovery is like finding a missing piece in the cosmic jigsaw puzzle of our solar system's formation. It challenges our understanding of how planets are formed and where their materials come from. So, buckle up, space enthusiasts. We're about to embark on a journey that will take us deep into the heart of this groundbreaking research. Are you ready to dive into this cosmic mystery? To unravel this mystery, we need to delve into the microscopic world of isotopes. You might be wondering, what are isotopes? Well, they're versions of an element with different numbers of neutrons, giving them different masses. But why are they important? Isotopes act like fingerprints, offering us unique clues about the history of our solar system. Now let's talk about some very special isotopes found in rare metals such as titanium, zirconium, and molybdenum. These metals are like time capsules, preserving the isotopic composition of the material from which they formed. By studying their isotopic ratios, we can trace back the origins of these metals, and by extension, the origins of Earth and Mars. Imagine a detective story where the isotopes are the tiny clues leading us to the origins of our planets. Each isotope ratio we measure is another piece of the puzzle, another step on the journey to understanding how our solar system came to be. But here's the tricky part. These isotopic clues are incredibly tiny, and analyzing them requires cutting-edge technology and meticulous techniques. It's like trying to read a book written in a language that only a few people in the world can understand. In spite of the challenges, scientists have made remarkable progress in deciphering the isotopic clues embedded in these rare metals. And what they've found is truly astounding. These tiny particles hold the key to our planetary past. Meteorites. These cosmic time capsules serve as reference points for our journey back in time. They are the remnants of the early solar system, fragments of rock that have traveled through space for billions of years, unaltered by the processes that have changed the planets. Two types of meteorites, in particular, can help us solve our cosmic puzzle: carbonaceous and non-carbonaceous chondrites. Think of them as the breadcrumbs left behind by the planets as they formed. Carbonaceous chondrites are thought to originate from beyond Jupiter's orbit, while non-carbonaceous chondrites hail from closer to the Sun. These chondrites are like miniature time capsules. Each one contains a unique mix of isotopes, versions of elements with different numbers of neutrons. By studying these isotopes, scientists can trace the origins of the meteorites, and therefore the planets themselves. Take titanium, zirconium, and molybdenum, for example. These rare metals are found in both types of chondrites, but their isotopic compositions differ. By comparing these isotopes, scientists can determine where in the solar system the chondrites, and by extension the planets, originated. This isotope sleuthing might seem like a bit of a cosmic treasure hunt, and in many ways it is. But it's more than just an exciting adventure. It's a way for us to understand our place in the universe, to uncover the secrets of our planetary origins. So next time you see a shooting star, remember this: these alien rocks bring us closer to the truth. Welcome to the virtual lab, where we use advanced technology to simulate the past. Here in the digital realm, scientists are able to create and manipulate virtual environments, essentially recreating scenarios from our cosmic past. This isn't some kind of science fiction, but a real and integral part of our quest to understand the origins of Earth and Mars. Think of these computer simulations like a cosmic sandbox. Scientists can toss in all the ingredients that make up the early solar system, then stir them around and see what happens. They can adjust variables, such as temperature, pressure, and time, to mimic the conditions of the early solar system. A crucial part of these simulations involves calculating isotopic ratios. Isotopes, remember, are variations of the same element with different numbers of neutrons. By comparing the isotopic compositions of different celestial bodies, scientists can trace back their origins and paths of travel. In the case of Earth and Mars, scientists use these simulations to calculate the isotopic ratios of certain rare metals, like titanium, zirconium, and molybdenum. They then compare these calculated ratios with the actual ratios found in meteorites and in the Earth's mantle. But the simulations don't stop there. They also help to simulate the process of planetary accretion, the slow and steady gathering of cosmic dust and gas to form planets. By virtually recreating this process, scientists can better understand how Earth and Mars formed and why their isotopic compositions are the way they are. These simulations are a bit like time travel. They allow us to journey back billions of years, to a time when the solar system was just starting to form. They help us to visualize and understand processes that are otherwise too grand and too ancient to comprehend. In the end, these virtual experiments are a testament to human curiosity and ingenuity. They're a reminder that even though we're tiny specks in a vast universe, we're capable of unraveling its biggest mysteries. These simulations bring us one step closer to understanding our cosmic origins. But there's a catch. A part of our history has managed to evade our reach. Imagine a cosmic game of hide and seek, where the hider is a portion of the building material from the innermost solar system, and we, the seekers, have been left scratching our heads. This lost building material, as we've come to call it, is a little bit like the missing piece from a jigsaw puzzle. You see, during the early stages of our solar system's formation, a significant amount of material was present in the inner regions, closer to the Sun. As planets like Earth and Mars were forming, this material was incorporated into their makeup. However, due to various cosmic processes, some of this material managed to hide away, escaping our direct detection. This elusive material is the last piece of our planetary puzzle. It's the final chapter in the story of how our red worlds, Earth and Mars, came to be. The findings from this research have changed the way we understand planet formation. We've learned that Earth and Mars owe their existence to a mere 4% of cosmic material from beyond Jupiter's orbit. This revelation, backed by isotopic evidence and virtual simulations, forces us to reimagine our red world's geological history. It's a cosmic detective story, with meteorites as time capsules and lost building materials adding to the intrigue. The cosmos is full of surprises. What other mysteries do you want us to explore? Drop your thoughts in the comments below.